Hello students, so we were discussing about a topic that is a conservative and a non-conservative forces. Today we'll be discussing that work done by or against the conservative force is independent of the path followed by the body. Okay, work done by or against conservative force is independent of the path followed by the body. We have to explain this statement by doing a mathematical proof. Let us see through it. I have taken two conditions. This is the first condition. Okay, this is the first condition in which we are lifting an object from the ground to this point up till height h. Okay, from the ground up till height h, and the work done is suppose W. Clear? Okay, we have the work done is W. So if you go to the next diagram, that is to the second diagram, we have an object A. Same, we are lifting to the same to the point B, having a height h. Height is the same. Height of both the diagrams are the same. But we are not, here it is following a straight path. Here we are not following a straight path. We are moving from A to B, B to C, C to D, D to E, E to F, then F to G and G to H. So it is traveling in that way. And each and every one, this W1, W2, W3, W4. That means for each and every part, how much amount of work done, we have written with W1, W2, W3. We have to see in both the condition what is the work done. Okay, in both the condition what is the work done, that we have to see. Let us first find out for the first condition. For suppose this is figure A, this is figure B. Okay, work done in figure A. Okay, work done in figure A. Work done, we know W is equals to, it is force into displacement. Force into displacement, force how much will apply? Will apply a force because this object will be having a gravity towards the downward direction by an mg. And how much displacement you have done? Your displacement done by h. So force will be, you have to apply a force equals to mg and the displacement is of h. Okay, next we have, this is the work done for the figure A. Work done for in figure number B. Figure number B. W equals to, you see how much amount of work done you see. First is W1 from A to B. From B to C we have W2. C to D we have W3. So we have to see how much amount of work done. W1, W2, W3, then we have W4, we have W5, W6 plus W7. We have total 7 work done are there. Okay, 7 work done are there. So if I go on adding it, firstly you see, I have written in the side of the diagram, you see, from A to B, height is h1, C to D, your height is h2, E to F, your height is h3, and Z to H, his height is h4. Okay, h1, h2, h3 and h4. From B to C there is no height. D to E there is no height. F to G there is no height. Okay, there is no height. So if I want to consider for the W1, we can write as mg into h1. Force into its height plus W2. You can see from B to C. This part, this is a horizontal part. That means there is no height at all. Work done will be equals to 0. Okay, next we have W3. W3, what we have? Again we have mgh2 plus W4 is from D to E. Again horizontal part 0. W5 we have mgh3 plus again W6 we have 0. Then we have the last one, that is mgh4. Clear? So what we can do, we can take mg as common. So it will be h1 plus h2 plus h3 plus h4. Okay, I have taken h1, h2, h3, h4 as common. So what I can write, if I add h1, h2, h3 and h4, what I'll get? I'll be getting the total height. So in place of this, I can write as mgh. So you can see in equation 1 and equation 2. Equation 2 we have got work done is equal to mgh. Equation 1 also we have got work done is equal to mgh. That means the work done in both the figures are the same. So what does it conclude? It concludes that from equation 1 and 2, it is clear that work done in figure A and figure B are same. Okay, work done in figure A and figure B are same. So you have to write work done by or against the conservative force is independent of the path followed by the body. Okay, so this is about the statement and you have to write it about it. Okay, so in the next class, we'll be discussing some more topics related with the work, energy and power. So thank you for today. We'll continue in the next class.